So let's first understand what do we mean by the numbers, right? So let's just look at number line first, which we would have done back in our childhood, right? So to the left extreme we call it as minus infinity to plus infinity, right? Every number in this world should lie in between these, right? So the one in the middle we call it 0. To the right we have positive numbers like 1, 2, 3, 4 and so on. To the left we have minus 1, minus 2, 3, minus 4 and so on, right? And then between 0 to 1 we have decimals, that's what we call them. Like let's say this is 0.5, this can be 3.6, etc, etc, right? Like minus 0.5. So we have talked about integers. There are zeros, ones, twos, minus ones, decimals, right? A minus 0.5, minus 1.5, etc, and lot more, which we'll cover in the next few minutes. Before that, just a couple of concepts on the number line per se, right? The number line goes from minus to infinity, so minus infinity to plus infinity. So understand that the value also keeps increasing. That means, so minus 4 is less than minus 3 is less than minus 2, 0, 1, 2. This is very clear to our mind that 2 is greater than 1. But I see few of students getting confused between minus 4 and minus 3, because 4 is greater than 3. They might think minus 4 is greater than minus 3. When you see the negative sign, understand that the lower the number is, larger it is, right? So that's an important point to be noted in the number line. So now let's get started with some terms. So these terms per se would not be the direct questions that you see in the exams or any competitive exams or anywhere as such, but these would be the words in the questions. If I say, let's say x is a real number or x is a positive integer, so what do they mean by that, right? Unless you have a better understanding of it, you might not actually be able to solve the problem sometimes. So first, the real and complex numbers is the very basic difference. So real numbers are the ones which we have discussed earlier as well, like 1, 2, minus 1, minus 5, all the integers, decimals, right? 2.3, 2.3, 4, 6, 7 and so on, non-ending ones, etc. Right? Whereas the complex ones are one which you would have, if you have seen anywhere. So square root of 4 is 2, to be very precise, it's plus or minus 2. When it's square root of some minus value, right, it's basically called I imaginary number. So that's basically a complex number would be of the form of this a plus bi, where a and b are real numbers. So basically, to just put it in simple terms, if you have this I imaginary number, the square root of minus, so we call them complex. Other than that, they are real numbers. So let's get in the real numbers, the set that's called integers. So positive integers, negative integers, also you have something called non-positive or non-negative, right? So positive are basically 1, 2, 3, like 100, 1000, right, and so on to infinite, right? Negatives are minus 1, minus 2, minus 3, minus 100, minus 1000 and so on up to minus infinity, right? 0 is the one which is neither positive nor negative. So that's where these things come in. When I say non-positive, I should count 0 and negative, because it's just not positive, right? If I say non-negative, you just have to take 0 and positive. If I say positive, just take positive integers. Negative, just negative. Non-positive is basically 0 and the negative as well, right? Then the natural numbers are basically positive integers in a way. It's like 1, 2, 3 and so on up to infinite. And the whole numbers are natural numbers plus 0. So that's basically 0, 1, 2, 3, so up to infinite. Right? If I talk in these terms, these are positive integers. These are non-negative integers in a way. Right? So these are commonly used per se, natural and whole numbers. So keep in mind, because I say like x is a natural number, right? And then you have to be clear what are the potential values of x and solve the equation or the question accordingly. So if you're not clear if 0 is part of it or not in a natural number or negative, it might actually give you a wrong answer. So be careful on that part. So let's get to the decimals. That's another type. So whichever are not integers but real numbers, we call them decimals, right? So in decimals, you have two types. So that's terminating and non-terminating. So when I say terminating, let's say 3 by 10 as a fraction is basically 0.3, right? So it's ending here. It's 0.300. So it's basically ending here. Let's talk about 22 by 3. 3 sevens are 21, and then I have 3, 3, 3. It keeps going on. If I do right, like the normal division, if we do, so right, if you see, always I'll get 1, 0, and it keeps repeating in this loop of 7.33333. So if you see a repetition of pattern happening, right? So basically 3 is repeating, so I can write this as 7.3. If there is something like a decimal 6.252525, I can write it as 6.25 with a bar on the top. What does that mean? It means it's a non-terminating. That is, terminating is basically ending, right? So here it is ending, it is not ending here, it is going on and here as well. So it's a non-terminating decimal, but it is having a pattern where it is repeating as 25, 25, 25. Here it's 7.333, etc. If you have a number like 6.43748 and so on, it's not ending, right? This is basically called a non-terminating, as well as there is no repetition of pattern happening as well, right? This basically occurs for irrational numbers per se. So a very technical definition of rational number is basically if I can write a number as a by b form, where right b is not equals to 0, then a number is a rational number. That means 3.3 can be written as 3 by 10, 7.33 can be written as 22 by 3, all the integers 2 minus 1 can be written as 2 by 1 minus 1 by 1. So all of these are rational, right? Even the integers and all the terminating and non-terminating ones as well, with some patterns, etc. The ones where you don't see like what is square root of 3, it's basically 1.712 something something, right? Our pi is 3.14 and so on. So we approximate it to 22 by 7 as fraction, but that is not how you get this. So understand, these are the irrational numbers. Basically when I can't write a value, it stays in decimals only, or it can't be written as a fraction, right? So those are the irrational numbers. Right, so let's get solve some problems to revise the concepts. They're saying which of the following is greater? 677.76. I'm seeing a bar on the top, right? That means it's a decimal which is non-terminating and goes on with the repetition of pattern, right? The other one is 677.765, 765, 765, etc. See, when we try to find the value of decimal, 23 is less than 23.001, is less than 23.002, at less than 23.1, basically 100, right? It's 100 is 2, this is 1 in a way. So similarly, if I am trying to compare these two, these are same, so automatically I'll look at the decimals. 7 and 7 first digit after decimal point, 6 and 6 is same, then I see 7 and 5, so 7 is greater than 5, right? So that means this one is greater than this one. So that's how we decide the answer for this.